By the end of this video, we'll learn how to create this responsive and real-time chart, which represent real-time data that is coming from Firebase. And here is our application that is connected to Firestore, and the data inside Firestore is represented in real time here in the chart. If we delete or update or insert a new data into our Firestore, it should be detected automatically by our application. And let's test this. We can add a new document and make an auto ID for this document, and we should create the temperature field here, which should be a number, and we add 99, for example, as a value for the temperature, and we should add a field which is the time, and it is of type timestamp. We select the current timestamp, then we click on save. We should see this new document represented in our chart. Okay, let's see together if it is added. Okay, we can see it is added successfully here, the date which is 10 December, and the value 99. Now we can modify also the documents, and the changes also should be directly detected by our application. For example, here I will make it 66, and we should see this change directly into our application. We can see it is modified successfully, and we can delete a document, and we should see that it is also deleted in our chart. Okay, start deletion. Then we can see here that we have only 3 elements, and the fourth element is deleted from our chart. We can conclude that our uh, chart and application is representing real-time data. So we have to create an Angular project, and in order to do that, we have to go to the directory in which we are going to create our project. We have to type cmd, as I am using command Windows, and in order to open a command prompt in the directory, we just have to type cmd. Then I type enter. Then I have to install Angular using using npm install -g Angular CLI, and wait until it's installed. As we can see here, it's installed successfully. The next step is to create the project using ng-new and the name of the project. Okay, I will call it 3 ESP 8266 Firebase Angular Firebase chart. As I will use the ESP later, the IoT module ESP8266. We wait until our project will be created. I will type yes. I will use CSS, and we will wait about 2 to 3 minutes in order to create get our project created successfully. And finally, we get this message. We are sure that our project is created. We have to navigate to it using cd and the name of our project. Then we open it using vscode. I will use this command to open the project using vscode code dot. Okay, we can see here that our project is created. There are several components that we can use using ng-zorro. For example, I will use some of these components for the layout. We can choose any layout. for example, this one or the other. We can see the codes here. We can copy the code or copy the command that generate the code for us, or show the code here. And based on this codes, I will create my layout. Okay. And using ng-zorro, I have added some code in order to create a sidebar and the layout of our application. I will explain to you briefly the code of the layout. We used the ng-zorro, as I said. We used the nz layout and as the nz cider for the cider here. Okay. And inside the cider, we have to the collapsible function, and we are using is called the boolean variable in order to make the collapsible possible. And inside of it, we added an image of the dashboard and an example a title. For example, I used the example dashboard here. Okay, and the icon here. And the theme I'm using is the dark. And for the inline collapsed option, we are using the variable is collapsed, as I said. And when we click on it, it's collapsed. Okay. And inside our and here we have two options: menu unfold and menu fold, depending on the variable is collapsed. And we should not forget to add necessary modules concerning the ng-zorro modules that we have used in our HTML component. These modules are nz icon, nz menu, react forms, nz layout. We should add their importations statements in the app.module.ts, as we can see here. So the next step is to add grid component based on ng-zorro grid components. So we have to go to ng-zorro, then type grid in the components section, and we can see here the details of how we can configure our grid component, the necessary syntax that we should use. So here we have each row is divided into 24 columns, and based on the value that we put, we get our partition. And for example, if you want two columns into our row, we should use column 12 two times, because 12 plus 12 equals 24. And if you want to divide our row into three parts, we have to use column 8, etc. Okay. And now I should add a grid component to my project, and to do that we simply type ng-generate component, and I will create a folder called grid, and I will put my component inside of it, and it will be called grid. Create until it's generated. You can see that it's successfully generated inside my grid folder. After that, I have to add the ng-grid module in order to use the ng-grid component in my project. I added its importation, and I add it into the imports list. After that, I have added some codes inside the grid HTML code, and I want later to put the chart above using all the row. Then I will divide the next row into three parts. Each part will contain some cards. And as we can see here, our grid is divided successfully. We have here above one row that will contain later the line chart, and below we have three columns. Each column will contain a card that will present some statistics that we will get after some calculations that we will perform based on the data that will update. And now the next step is the addition of a pie chart to our project. We add this library using this command and wait until it's added. You can see here that we don't have any vulnerabilities. We can use the next npm audit fix if there was some issues with npm using force mode to avoid errors. And as the documentation says, we should add the import statement into the app.module.ts. Now we can use our chart in our project. And now let's create a component that will hold the line chart that will contain the details and the data about temperature and humidity. That will be a line chart. And in order to do that, I use this command and I try to create the component inside the grid folder. Okay, let's see now. As we can see here, it's added here, the component. And inside this component, we are going to add the line options and HTML code of the line chart. And here are the options of our temperature humidity line chart component. We set the type, the text of the title. The x-axis will contain the list of categories, and for the data, we have to set list that contain the different values that will constitute our data and the name of each series. For the temperature, we have name and data, the same for humidity. And for the HTML part, we can create a division that contain the ID of the humidity and temperature chart. And during the initialization of the component, we have to create the chart using highchart.chart and the name of our chart and assign the options that we mentioned to this new chart. And this will be the ID that we have used inside the division in the HTML code. And for the grid component, we have to add the selector of the component that we already have created. And as we can see here, the charts are created successfully. The title is the same that we have created, and we have here the legend, and it is responsive and awesome. Now we have to create a Firebase project, and in order to do that, we have to go to this website, which is cancel.firebase.google.com, and create a new project by clicking on add project. We have to give a name to our project. I click on continue, then I click one more time on continue. I choose an account. For example, I will create a new account. I will call it our country. I accept. So we have to create a project. And now our project is created. We have to click on continue. And now we have our project is ready. After that, we have to create a web application inside our project by clicking on a web icon here. We have to give a name for our web application. For example, I will call it Google Map Angular. We can click on also set up hosting for this app. Uh, we click on register app. We can see here are all the commands that we will use in our Angular project and the configurations. We click on next. We click on next one more time. Here we have all the commands for the logging and initiation and deploy. After that, we finish by clicking on continue to console. Now we can see here that a new web application is created inside our project. We click on this icon and we can see all the details of our web application inside our. And once we have to use Firestore in our Angular project. We have to create a Firestore database. We can say test mode here. We click on enable, and now Firestore database is created successfully. And we can modify here the rules in order to extend the testing period. Here we can see, yes, we can see 23 here, so that we won't have an issue for dates and expiration dates. Okay, I will click on publish, and you can use the data and this first store until the next year. Okay. And now we have to add Firebase to our project, and in order to do that, we just use this command and wait until it's added to our project. Okay, now it is added successfully to our project. After the creation of, after the installation of Firebase into our project, we have to log in using Firebase login. A window will open for us to sign in. We choose the mail that we have used to create the Firebase project. For me, this the email. Then we should say hello. Okay, now we are logged in successfully, and here a message in the terminal that we are successfully connected. After that, we have to initialize Firebase, and we should use Firebase init. We should say yes features that we want to use. We can type A to select all the options. We will use an existing project. Okay, now we should select a project. We can go to Firebase console and uh, take a look at the projects. For example, for this project, we can check its settings. We can see here the ID is map chart angular. So I will use it, this one. We can type enter, enter one more time, enter one more time. These are files for the configuration of Firebase. Yes, should install the dependency. You can say yes for using our public directory. Emulators, we can say yes for all of them. Yes. And now the installation and initialization is complete. We can work with the Firebase with no issues. After that, we have to add the Angular Fire module and the Angular Fire Analytics module, Angular Firestore module to our Angular app module and add them to the list of imports here. Here are the modules. We add them in the imports list. Then we should add the environment.firebase. And in the environment, we should add the details of configuration of Firebase of our project inside Firebase, especially the API key. And now we are going to create a service that will handle our connection with Firestore in Firebase. And in order to do that, we have to simply use ng-generate service and the folder that will contain our service, which I will call services, and then one subfolder that I will call it Firebase charts, for example, or temperature temp humidity charts. Then the name of the service will be Firebase PMP view. Okay, that it is created, and inside of it we will put all the necessary code to maintain our connection with Firestore. And now let's create an interface for our temperature. Then we should create a folder for it. We'll create here in the app. a new folder which I will call models, and inside of it I will create another folder which I will call charts, and inside of it I will create a new file which I will call temperature humidity or temperature interface.ts, and inside of it we will declare our interface. Then inside our service we should add all the necessary importations, and we should not forget the temperature model that we have already created. Then let's declare a variable which will be called the temperature collection inside our class. Then we will add an observable. After that we will make dependency injection inside the constructor, and inside our constructor we'll add this code that will detect any changes in our file store. Then it will load the new data for each change. And here inside our service we have a type, parameter of type Angular file store collection, which is called temperature collection. And here the temperature collection is the interface that we have created, which have parameters like the ones inside the Firestore collection. And we created an observable of type temperature model, and there will be an array of temperature modules, which means that will be array, and each element of the array will have here the temperature and the time uh, parameters, and the constructor here inside of it we have injected a Firestore service, and this Firestore service will allow us to detect any changes later, and for our temperature collection that we have created, it will take as a value the Firestore service dot collection, and we should put the name of our collection inside the Firestore. As you can see here, it is called temperature data, and it is the same name that we have put inside our service, which means also that whenever a change that occurs in the Firestore, the new data will be updated and added to the temperature data. Now, inside the TypeScript of our component, we have added some modifications here. We have added the Firebase temperature humidity service that we have already created and explained. And inside the constructor, we have added an object of type the service, and some arrays that will appended with the data that is coming from through the service. And here, when our component is initialized, we subscribe to the observable temperature that is created here using the object service here. And for each element that is coming from the subscription, this object will contain the new data that is coming from Farso. Okay. Then, if we have data for each element in the temperature data, we have a row here, and this row will contain the temperature and the date. For the temperature, it will be appended directly into the temperature values. But for the date, which is called time here, we have the seconds here in the time that is coming from Firestore. We should convert it to the valid date format using this formula, and the temperature timestamp then will be pushed by this new temperature time date format that we got. And categories here will contain the temperature timestamp, and the series 0 here will contain the data. And finally here we create a chart. Options will be here, the title, the credit, etc. And for the categories here, as I said, it will contain the timestamp that will contain itself the data that's come from Firestore and converted. And for the series and the data, it is coming also from the Firestore and using the subscription. And here is our application that is connected to Firestore, and the data inside Firestore is represented in real time here in the chart. If we delete or update or insert a new data into our file store, it should be detected automatically by our application. And let's test this. We can add a new document and make an auto ID for this document, and we should create the temperature field here, which should be a number, and we add 99, for example, as a value for the temperature. And we should add a field which is the time, and it is of type timestamp. We select the current timestamp, then we click on save. We should see this new document represented in our chart. Okay, let's see together if it is added. Okay, we can see it is added successfully here, the date which is 10 December, and the value 99. Now we can modify also the documents, and the changes also should be directly detected by our application. For example, here I will make it 66, and we should see this change directly into our application. We can see it is modified successfully, and we can delete a document, and we should see that it is also deleted in our chart. Okay, start deletion. Then we can see here that we have only three elements, and the fourth element is deleted from our chart. We can conclude that our chart and application is representing real-time data.